Hello everyone. Due to this COVID pandemic and lockdown situation, many students are facing a lot of problems regarding their studies and how will they prepare for their exams, schools, books, etc. So I have planned to make some videos, especially for the school students regarding their studies in science topics. And today I will start Science of Class 8 CBSE. In CBSE Class 8, science consists of 18 chapters. But among these 18 chapters, 3 or 4 chapters have linked with their previous syllabus, previous classes like class 7 and class 6. So instead of starting from the very first, that is crop production and management, I will start with those linked chapters such that students find it easier to connect with those things from their previous classes to this class in this transition period. Today I will start force and pressure. Everything comes with its definition, and so we will proceed. Force. What is force? In many of books you will find a common definition, that is a push or pull is known as force. But I will say it a bit differently. Okay, just see. Any external action or cause due to which an object changes or tends to change. Mind this word very carefully, okay? Its position, shape and size is known as force. So what is force? Now the external cause, that is force. And due to this external cause, what happens? An object either totally changes its position, shape or size, or tends to change. Okay, what do you mean by tends to change? See, I'm moving this pen from here to here. This is actual changing of position. But when I push this wall, okay, this wall doesn't change its position, but it tends to change its position. If we increase the force and instead of using my hand, if I use a bulldozer, it will definitely change its position. Okay, so we will use these two words: changes or tends to change its position, shape and size. What do you mean by shape and size? Squeeze a ball, its shape and size will change. That's also application of force, right? Okay. After this definition, we will come to the unit. For the sake of our measurement, we use proper units of each and every physical quantities. Now, generally we use two types of units for measuring our physical quantities. There are other units also, FPS, MKs, there are other units, but we will use two units. What are those? Physical quantities are measured by units, and we will use SI units, International System of Standards, and CGS unit, centimeter gram second. Okay. Now, what a force does? A force, for good example, take this. A force is changing its position from here to here, right? With respect to time, it changes its position. So, suppose this block has a mass of 1 kg and it takes 1 second to come from here to here. Okay. From laws of motion, we get a definition that I will not discuss today. I will discuss in other topics, other day. That is, force is defined as product of mass and acceleration. Okay. From here, the unit comes. What is acceleration? Acceleration means change of velocity with respect to time. With time to time, when the velocity changes, increases or decreases, then it is known as acceleration. Okay, the rate is known as acceleration. So from this definition, we will form the unit of force. So what is the unit of mass in SI system? It is kg. In SI system, the unit of mass is kg. And what is the unit of acceleration? Rate of change of velocity. That means velocity by time. Velocity means meter per second, and by time means another second. So meter per second square in SI. Okay. So unit of acceleration in SI system is meter per second square. This is the unit of force, kg meter per second square in SI system. And in CGS system, what is the unit? That is, instead of kg we will use gram for CGS. Centimeter gram second. The name suggests the unit. Okay. In CGS we will use gram instead of kilogram. Instead of meter, what we will use? C for centimeter. That is gram centimeter, and second is common for both. So in CGS it will be gram centimeter per second square. Now this kg meter per second square is termed as Newton. This is known as absolute unit of force, absolute SI unit of force, and this gram centimeter per second square is termed as dyne. Okay. Now we will form the dimension of force from these units. Okay. The dimension of mass is represented as capital M enclosed by third bracket. Similarly, the dimension of distance or length, whatever you say, is represented as capital L enclosed within third bracket, and the dimension of time is represented by capital T enclosed within third bracket. Okay. Using these three, we can form the dimension of force. How? Kg, that means mass, M, dot, that means multiplication, meter, what is the physical quantity, which physical quantity meter represents? Length or distance. So for length we will use L, by time square. Second square means time square, then by time square. Now we will change it into a simpler form. There is a chapter in mathematics known as laws of indices. Okay. There one formula I am telling you. A by B to the power n. N can be anything. 1, 2, 3, 4, anything. Okay. This can be written as A into B to the power minus n. Whenever the denominator comes above, the power just is preceded by an opposite sign. If there is, suppose if it is b to the power minus n, then it will be b to the power m. Power becomes just opposite. Okay. The same logic we will apply here. So the dimension will become m l t to the power minus 2. See? Here it is only 2 and the sign will just opposite, I have said. But always remember one thing, when you are writing the dimension, don't forget to enclose it within third bracket, otherwise it will be wrong. Okay. So this is the dimension of force, m l t to the power minus 2. I have completed up to this portion. Note it down.